So today we discuss about where the method of differentiation under the sign of integration is used. By this method, by this method, the values of definite definite integral. By this method, the values of definite integral uh, definite integral is obtained, which are not easily integrable. By this method, the values of definite integral is obtained which are not easily integrable. In this method, in this method, first differentiated integrand integrand in this method, first differentiated integrand with respect to the parameter with respect to the parameter which is independent from the from the limit of integration. So by this method, the values of definite integral is obtained which are not easily integrable. In this method, first we differentiate integrand with respect to the parameter which is independent from the limit of integration. So on this method, we take one question. So here we solve the integral, given integral I is equal to integration of log 1 plus cos alpha multiplied by cos x divided by cos x dx. Suppose this is first equation. Here we can see this limit 0 to pi by 2. This is the limit of x variable f. Here x going from 0 to pi by 2. And here the quantity alpha is independent from the limit of integration. So alpha is the parameter. Here we can see the limit of this integration is 0 to pi by 2, and this 0 to pi by 2 is the limit of x. So x going from 0 to pi by 2. Here the quantity alpha is independent from the limit of integration 0 to pi by 2. So alpha is the parameter. So for evaluating this integral, first we differentiate this integral with respect to the parameter alpha. So differentiate with respect to parameter alpha. So here di by d alpha, this is equal to d by d alpha of integration of log of 1 plus cos alpha multiplied by cos x divided by cos x between the limit 0 to pi by 2. Here d by d alpha goes inside the integral sign, it converts partially. So here we use Leibniz rule. When this differentiation sign goes inside the integral sign, it changes partially. So d by d alpha can be written as del by del alpha. 1 plus cos alpha cos x divided by cos x dx. Here we have to evaluate this integral I is equal to log of 1 plus cos alpha multiplied by cos x whole divided by cos x between the limit 0 to pi by 2. So first we suppose that this is equation 1. Here the limit of integration going from 0 to pi by 2 and this limit is of x. So x going from 0 to pi by 2. Here the quantity alpha is independent from the limit of integration. So here we differentiate first with respect to the parameter alpha. So di by d alpha is equal to d by d alpha of integration of log 1 plus cos alpha cos x divided by cos x between the limit 0 to pi by 2. We know that when d by d alpha goes inside the integral sign, it converts into partial differentiation. So d by d alpha when goes inside the integral sign, it converts in partially, that is del by del alpha. Now we differentiate this partially with respect to alpha. Here we can see this cos x is constant with respect to alpha, because here we differentiate this with partially with respect to alpha. So cos x is constant here. Now we differentiate del by del. Now we differentiate log of 1 plus cos alpha multiplied by cos x partially with respect to alpha. So this can be written as, we know that differentiation of log x with respect to x is 1 upon x. So the differentiation of log of 1 plus cos alpha multiplied by cos x is 1 upon 1 plus cos alpha multiplied by cos x. Now we differentiate 1 plus cos alpha cos x. So differentiation of 1 with respect to alpha is 0 because it is constant. When we differentiate cos alpha multiplied by cos x with respect to alpha, so cos x is constant because here we differentiate this partially with respect to alpha. So cos x is constant. And differentiation of cos alpha with respect to alpha is minus sin alpha. Here we differentiate log of 1 plus cos alpha into cos x partially with respect to alpha. So differentiation of log 1 plus cos alpha multiplied by cos x partially with respect to alpha is 1 upon 1 plus cos alpha multiplied by cos x. Here 1 is constant, so differentiation of 1 with respect to the parameter alpha is 0. Here when we differentiate cos alpha multiplied by cos x, so cos x is constant because we differentiate this partially with respect to alpha. And differentiation of cos alpha with respect to alpha is minus sin alpha. Here we can see this cos x cancelled by this cos x. And now we can see here, now we can see di upon d alpha, this is equal to 0 to pi by 2 minus sin alpha divided by 1 plus cos alpha multiplied by cos x dx. Now we integrate this. Here we can see this sin alpha with respect to x is constant, so it will take outside the integral sign. So this is minus sin alpha integration between the limit 0 to pi by 2 1 upon 1 plus cos alpha multiplied by cos x dx. This is equal to di by d alpha. Now we integrate 1 upon 1 plus cos alpha into cos x. So we put here value of cos x. So cos x can be written as, here value of cos x can be written as 1 minus tan square x by 2 divided by 1 plus tan square x by 2. Here in place of cos x we put 1 minus tan square x by 2 upon 1 plus tan square x by 2. Now we are taking LCM in the integral sign. We can see here this 1 plus tan square x by 2 goes into the numerator. So 1 plus tan square x by 2 dx. Divide by, here this 1 plus tan square x by 2 multiplied by 1, this is 1 plus tan square x by 2 plus cos alpha multiplied by 1 plus 1 minus tan square x by 2. When we take LCM here, 1 plus tan square x by 2, so 1 plus tan square x by 2 goes into the numerator and 1 plus tan square x by 2 multiplied by 1. Now this can be also written as, di upon d alpha. This is equal to minus sin alpha integration between the limit 0 to pi by 2. This 1 plus tan square x by 2 can be written as sec square x by 2 dx divided by, here this 1 plus tan square x by 2 plus this cos alpha multiplied by 1, this is cos alpha minus cos alpha multiplied by tan square x by 2. Here we open the bracket and multiply by cos alpha. So cos alpha multiplied by 1 we get cos alpha, and minus cos alpha multiplied by tan square x by 2 we get cos alpha tan square x by 2. Now we can see here, this di upon d alpha, this is equal to minus sin alpha between integration between the limit 0 to pi by 2 sec square x by 2 dx divided by 1 plus cos alpha plus 1 minus cos alpha multiplied by tan square x by 2. Here we take common tan square x by 2 in the denominator, and now we taking common 1 minus cos alpha. So here we can write minus sin alpha upon 1 minus cos alpha integration between the limit 0 to pi by 2 sec square x by 2 dx divided by 1 plus cos alpha upon 1 minus cos alpha under root whole square plus tan square x by 2. Here we put t is equal to tan x by 2. Now we differentiate this with respect to x, so we get dt upon dx. This is equal to sec square x by 2, and differentiation of x by 2 we get 1 by 2. So from here we write 2 dt is equal to sec square x by 2 dx. So we put here di upon d alpha, this is equal to minus sin alpha divided by 1 minus cos alpha integration. Here sec square x by 2 dx can be written as 2 dt divided by under root 1 plus cos alpha upon 1 minus cos alpha whole square plus t square. Here the limit of integration will be changed. Here the limit of integration will be changed when x is 0, t is equal to tan 0 by 2, that is 0. When x equal to pi by 2, so t is equal to tan pi by 4, and tan pi by 4 this is equal to 1. So the limit going from 0 to 1. Here we integrate this minus sin alpha upon 1 minus cos alpha, and 2 is constant. We integrate this, so integration of this 1 upon a under root 1 plus cos alpha upon 1 minus cos alpha, tan inverse x upon a, so t upon under root 1 plus cos alpha under root 1 minus cos alpha, 0 to 1 here. Now we can see here, if we cancel this 1 minus cos alpha, there will be under root 1 minus cos alpha. So we cancel out this 1 minus cos alpha, there will be 1 under root 1 minus cos alpha. And under root 1 minus cos alpha, under root 1 plus cos alpha, this can be written as under root 1 minus cos square alpha. And 1 minus cos square alpha, that is sin square alpha. So this can be written as minus 2 sin alpha divided by sin alpha. And here we apply upper limit in place of t. So we get here tan inverse under root 1 minus cos alpha divided by 1 plus cos alpha, minus in place of t we put here lower limit, that is 0. So tan inverse 0 is 0 here. Now we know that this sin alpha is cancel out, so this is minus 2, and here under root 1 minus cos alpha, this is 2 sin alpha by 2. So here we write tan inverse 2 sin alpha by 2 divided by 2 cos alpha by 2. So this 2 is cancel out. Here we can write minus 2 tan inverse tan alpha by 2. So this can be written as minus 2 multiplied by alpha by 2. So 2 is cancel out, so this is minus alpha. So di by d alpha is equal to minus alpha. Now we solve this. Now we solve this again here. Now we solve this here. Now we solve di by d alpha, this is equal to minus alpha. Now we integrate this with respect to alpha, that is di is equal to minus alpha d alpha. Now we integrate this, so we get integrate, we get I is equal to minus alpha square by 2 plus integration constant c, where c is the integration constant. Suppose that this is equation second. Now we put alpha is equal to pi by 2. We can see when we put alpha is equal to pi by 2 in given integral 1. So I is equal to integration of 0 to pi by 2 log 1 plus cos pi by 2 multiplied by cos x divided by cos x dx. We know that cos pi by 2, this is equal to 0, so it becomes integration 0 to pi by 2 log of 1 divided by cos x dx. And we know that log 1, so this can be written as here 0 to pi by 2 log 1 divided by cos x, because log 1 is 0, so this integral is 0 when we put alpha is equal to pi by 2 in the given integral. Now we put alpha is equal to pi by 2 in equation second. Now we put alpha is equal to pi by 2 in second, so we get pi by 2 is equal to, here we put alpha is equal to pi by 2, so we get here pi square by 8 plus c. We know that I is equal to 0 when alpha is equal to pi by 2, so we put here 0 is equal to minus pi square by 8 plus c, so c is equal to minus pi square by 8. We can see here di by d alpha is equal to minus alpha, so we integrate di is equal to minus alpha d alpha, so we get I is equal to minus alpha square by 2 plus integration constant c. Put alpha is equal to pi by 2 in the given integral in place of alpha, that is I is equal to integration 0 to pi by 2 log of 1 plus cos pi by 2 into cos x divided by cos x, and we know that cos pi by 2 is equal to 0, so this integrand is reduces log 1 upon cos x, and we know that log 1 is equal to 0, so so the value of the integral I at the point alpha is equal to pi by 2, this is equal to 0. Now we put alpha is equal to pi by 2 in the in second, so I is equal to minus times pi square by 8 plus c, and we know that I is equal to 0 when alpha is equal to pi by 2, so in place of I we put here 0 and c is equal to minus pi square by 8. Now we again put value of c in equation 2. Put value of c in 2, we get I is equal to minus alpha square by 2 minus alpha square by 2, here c is equal to plus pi square by 2. When we put value of c in equation second, so this is alpha square by 2 plus pi square by 8. Now we taking common here 1 by 4, so this is pi square by here we take common 1 by 2, so this is pi square by 4 minus alpha square. Sorry for this, here the value of the integration constant is pi square by 8, because when we transform this minus pi square by 8 in the left hand side, so c is equal to pi square by 8. So value of integration constant c is pi square by 8, and put in equation second, we get the value of the required value of the given integral, that is minus alpha square by 2 plus pi square by 8. Now we taking common here 1 by 2, so we get value of the integral, that is 1 by 2 multiplied by pi square by 4 minus alpha square. Thank you. Here we can see this is